For the following problem, we're given f of x equals x squared minus 5. We want to find the derivative, and we're given that f prime of x, or the derivative of f of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. The goal whenever we're doing one of these limit problems is to find f of x plus h, then simplify it by subtracting f of x, so that'll simplify our entire numerator, and then we need to cancel out this h in the denominator so that we can plug 0 in for h. Notice we can't plug 0 in right now because we would get division by 0, which is impossible. So the entire goal of this process is to get rid of this h in the denominator. We're going to start by finding f of x plus h. So f of x plus h is equal to x plus h squared minus 5. And x plus h squared is the same thing as x plus h times x plus h minus 5. And now we can start multiplying this out. So I'm going to go through this a little quickly. We have x squared plus hx plus hx plus h squared when we multiply all of these terms out, and we have a minus 5. So simplifying this, we get f of x plus h is equal to x squared plus 2hx when we combine this hx and hx together, plus h squared minus 5. And now that we have that, we can plug it into our formula. So we get the limit as h approaches 0 of f of x plus h is x squared plus 2hx plus h squared minus 5, and we're subtracting f of x, and f of x we just said was x squared minus 5, and this is all over h. You always want to make sure to put these terms in parentheses, the f of x plus h and the f of x, because in this case, and in all cases really, because we're subtracting f of x, we're going to have to remember to distribute that negative that's on the outside of the parentheses. So we're going to go ahead and do that. Note that every time you do this, you have to keep writing down that limit as h approaches 0. I know it's annoying, but it is required. So we get x squared plus 2hx plus h squared minus 5, and we don't need these parentheses anymore, minus x squared plus 5. And this is all over h. At this point, we can start simplifying our like terms. So again, we have the limit as h approaches 0 of x squared and negative x squared cancel out. Negative 5 and positive 5 cancel out, leaving us with 2hx plus h squared all over h. And now at this point, we need to cancel out this h in the denominator. And the way that we go about that is, notice we have a common h in the numerator. So we're going to factor that h out, giving us the limit as h approaches 0 of h times the quantity of 2hx when we factor out an h just leaves us with 2x, and then plus h squared when we factor out an h leaves us with plus h all over h. So we can cancel out the h's, giving us the limit as h approaches 0 of 2x plus h. And it's at this point that I was talking about earlier. Now that we've canceled this h out of the denominator, we no longer have the chance of division by 0, so we can now plug in this 0 for h. We don't need to consider it as a limit as h approaches 0 anymore. We can just say h equals 0. The limit as h approaches 0 was just there to say that h can't equal 0 yet. Otherwise, we would have division by 0. So with all of this, we now plug in that 0 for h. That gives us 2x plus 0, which is just 2x. So our derivative is f prime of x equals 2x.